This is Krishna Kumar Karotia. Today I would like to discuss about the refrigerant. In refrigerant we will discuss about different type of refrigerant, then first the designation of refrigerant, then their properties, physical, chemical properties and thermodynamic properties. Okay, then recent trend. Okay, so first there will be designation of refrigerant. So how we can designate the refrigerant? Okay, so in this we have the three cases. First is the saturated hydrocarbon, second is the unsaturated hydrocarbon, third is the inorganic refrigerant. Okay, so first we take the designation of refrigerant as a saturated hydrocarbon. So write down first case saturated hydrocarbon. In this, the chemical formula is given like C suffix M, H suffix N, F suffix P, Cl suffix Q. Okay, if the chemical formula is given, how we can designate it in term of R11, R12, R134. Okay, so what is the first process? First write down the equation 1 like R bracket m minus 1 bracket close bracket n plus 1 bracket close p. Okay, so this equation be correlate with the chemical formula. Okay, if the there is another equations like 2m plus 2 equal to n plus p plus q, that we will discuss. Okay, so this we will understand through the example how we can designate it. Okay, so take the first example. If the chemical formula is given like first example CCl2 F2. So how we can designate this chemical formula? What will be the name? Name you can directly tell. There is 2 chlorine, 2 fluorine, 1 carbon. So what will be the difluoromethane? Okay. So here this chemical formula we relate in equation 1. R minus R m minus 1 n plus 1 p. Okay, so here you can see the Cl2F2. Okay, so C suffix means m. So here what is the m equal to 1. So we put here m equal to 1, so this becomes 0. First term m minus 1 bracket term become 0. Okay, so R 0. Then n is there h, there is no h, so n become 0. So n be put in this equation, so what will become? The n plus 1 become 0 plus 1, so it become 1. Okay, then here is the you have Cl2 and F2 also you have. Okay, so if we compare P2, so we need F2, so F2 is there. Okay, so 2 is there, so P2 equal to 2. So we put this value in the equation first, R m minus 1 n plus 1 P. So what will be the R m minus 1 become 0, so R 0 n plus 1. So this is we find out the 1 and p equal to 2. So formula become R 0 1 2. Okay, so 0 can be drop out because it has nothing meaning here. Okay, so R12. So this is how we can designate the refrigerant. Okay, so this name will be difluoromethane. Okay, so let us take the second example. Write down second example R 2 2. Okay, so if the, or you can take the reverse, we will do later. First take this R22. Okay, let's take this R22. So here we can write R022 b. So 0 we can compare m minus 1 and 2 n plus 1 and 2 we compare with the p. So here m minus 1 equal to 0, so m become 1, n plus 1 equal to 2, so n become 1 and p equal to 1. Then again we need to find out if there is some chlorine molecules, because here the one bond will be there, CHF2. Okay, so it's not satisfied basically, so we need to find out with the help of the second equation, 2m plus 2 equal to n plus p plus q. Okay, so here what will be the 2m plus 2 equal to n plus p plus q. So we put m equal to 1, so this become 4 equal to n equal to 1, p equal to 2, so this 3 plus q, so q become 1, so Cl molecules will come. So final equation will be CHClF2. Okay, so this will be the monochloro difluoromethane. Okay, let's see next case. Like previous we done the reverse designation and find the chemical formula. So if the in previous section we have drive, uh, 1 minute, in previous, yes, here is the, in example 2 this is the basically reverse designation. Okay, so we will see some more example. Okay, here if we take R11, how we can make the chemical formula of this refrigerant and what will be the name of this refrigerant. Okay, so first R11 we make R011 and compare with the relations like M minus 1, N plus 1, P. So here will be, what will be, you have P equal to 1, directly you know, N plus 1 equal to 1, so N become 0, then M minus 1 equal to 0, M become 1. So we will see another chlorine molecule. So here N plus P plus Q equal to 2M plus 2. This is our formula. So N equal to 0 plus P equal to 1 plus Q we have to find out equal to 2, M equal to 1 plus 2. So Q become 3. So what will be the formula? Chlorine molecules will be 3. Then we know the chemical formula CmHnFeClQ. So we relate, we put these number M, N, P and Q in this chemical formula. What we will get? CfClQ. Okay, so this will be the chemical formula for the R11. And what will be the name of this? Trichloromonofluoromethane, because here you have 3 chlorine, 1 fluorine and C1 means methane. If the C become 2 then is ethane. Okay, so let us see another example. Write down example 2, R22. Okay, so first we will make R022, then we correlate this M minus 1, N plus 1 and P. Okay, so P here is a 2, then N plus 1 equal to 2, then N equal to 1. Similarly M minus 1 equal to 0, then M equal to 1. So we take the next equation like 2m n plus p plus q equal to 2m plus 2. So here what will the n, you have the 1, p you have 2 plus q equal to 2, m you have 1, so plus 2. So q will be 1. Okay, so q will be 1 means Cl molecules, chlorine molecule will be 1. Then we correlate this with chemical formula CmHnFeClQ. So what will be, you have, so you will get the C1, you have M equal to 1, so C single. Similarly N you have also N you have 1. Okay, here, and so H will be 1 molecule. Similarly chlorine you have Q also you have 1, so chlorine will be 1. P you have 2, so F in suffix में 2. Okay, so the formula becomes CHClF2. So what will be the name of this? There is a 1 chlorine, so monochlorine. There is a 2 fluorine, so difluoro, and there is 1 carbon, so methane. So monochloro difluoromethane. Okay, got it? And try some more example from your book and practice that, so you will become much familiar how to name it the refrigerant. Okay, let's see next. So if you take the one another example like R113, okay, so this is the 3 digit. So we here we don't need to put 0, okay. So what will be the m minus 1 equal to 1, then equal to 2. Similarly n plus 1 equal to 1, then n become 0, okay, and here p equal to 3, okay. So what you have, the C2 H0 you have F3 and Clq, okay. So this becomes C, 1 minute, C2 m equal to C2, okay. N equal to 0 means H we don't have, then P become 3, so Cl, so F3 will be there. Then you need to find out the Q molecule. So how we can find out? With the help of the that equation, N plus P plus Q equal to 2m plus 2. From there you can find out the Q equal to 3, okay. So what will be the relation for this? So it become C2F3 Cl3, okay. Then what will be the name of this? This become tetrachloro monofluoromethane. Let me see, 1 minute, okay. Tetrafluoro tetrachloro monofluoromethane. No, it's not. You check it out this, okay. And similarly if we take CFL, CFCl3, how we can designate it? Become the R11. So this will be, sorry, this name will be tetrachloromonofluoromethane, this R11 name, okay. Then similarly you can find out for the R134A. Here you will get the C2H2F4, okay. So what will be the name of this? C2H2F4 tetrafluoro, okay, and ethane, because here you have the two carbons, so ethane will come in picture, okay. But one more thing is there. If you write down simple R134, what the chemical structure of this? C, like this, okay. If we write this another form, like this is in symmetrical, and two isomer will be there, asymmetrical or symmetrical, okay. So if there is R134A, so how the structure of R134A? That will be like here, the upper C single bond, then F F H H F F, okay. So if the structure or is like that, then this we say R134A. Although the chemical formula is the same, but it have two isomer, okay. Like here the CCHHFF. If the above part you have the HH molecules and all around the fluorine molecule, then it is symmetrical, then it is R134A. If we manipulate this and this we write here CH, upper H, downward H, then single bond C, F, 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 and here also F you have, okay. So this we write generally R134A, and this is called the tetrafluoroethane, okay. So let's see next. And one more thing about this, here here this refrigerant generally used in our commercial refrigeration system, okay, very much. Second case, so write down case second, unsaturated hydrocarbon, okay. So chemical formula will be like CmHn FpClQ, okay. So if the, write down, if the chemical formula of refrigerant CmHn FpClQ, then such refrigerant are designated as, okay. unsaturated hydrocarbon. Okay, so for this write down R 1 m minus 1 bracket close. Okay, then bracket n plus 1 bracket close p, where the this is the equation 1, then next second equation here will be little bit change, n plus p plus q equal to 2m. Okay, so previous one you have just only r m minus 1 n plus 1 p, but here you have r1 m minus 1 n plus 1 p, and in second equation there will be change little bit, n plus p plus q equal to 2m. In previous equation you have 2m plus 2. Okay, but here only 2m. Okay, so there here also you have two equations. So let us see with the example. Okay, so like you have C2H4. Okay, write the designation for it. Generally C2H4 basically ethene. Okay, so we compare this CmHnFeClQ. Okay, so m equal to 2, n equal to 4, p you have 0, q you have 0. So what will be the formula? R1, 1 already is there, m we put 2, so 2 minus 1, and n we put 4, so 4 plus 1, and p we put 0. Okay, so what will be here the formula? R1150. Okay, so this will be for the R1150. Okay, so this is how we can designate the unsaturated hydrocarbon. So generally this series start with the 1000. Okay, whereas and previous one saturated hydrocarbon it start with the 10. Okay, generally 10 100 it and more generally. Okay, so let's see next. This is the second case, unsaturated hydrocarbon. Okay, all right. Then there is another third case. So write down case number third, inorganic refrigerant. Okay, or compounds. So generally this series we designate with the help of R bracket 7000 plus molecular weight bracket close. So in this series generally start with the 7000. Let us see how. So generally inorganic compound which are the NH3, CO2, H2O, air. Okay, like that. Sulfur dioxide also is there. Okay, so let us see first NH3, that is called the ammonia. So what is the molecular weight of the ammonia? N14, H3 means 14 plus 3 means 17. So we put this molecular weight here in formula, or R 700 plus 17. So what become R 717. So this formula become R 770. Similarly CO2, the molecular weight is 44, so is become R 744. Similarly for H2O, molecular weight of H2O 18, so this become R 718. Air, we generally take molecular weight of the 29 because it is the mixture of nitrogens and other oxygen and nitrogen. Okay, and then some other gases. So generally the molecular weight average is 29 we take here. So this become R 729. Okay, so here is the case 3. Okay, so case 3 generally start with 700, case 2 generally start with 1000, and case 1 generally start 1000. Okay, one more type is there, that write down 4 type. Azeotrophs, Azeotrops, azeotrophs. Okay, so this series generally start with the 500. Okay, and generally azeotrophs is the mixture of two and more refrigerant. Okay, so like we take R1 50%, we take R113 50%. So finally the what will be the properties, it depend on the mixture. Okay, so write down definition. Azeotrophs, it is the mixture of refrigerant. It is the mixture of refrigerant behaving as pure substance, behaving as pure substance is called azeotrope or azeotropic mixture refrigerant. Okay, so generally it is the mixture of two and more than two refrigerant. Okay, so here we finish today lecture, then tomorrow we will discuss the properties of refrigerant. Thank you.